The notes for today are section 14.5, transforming exponential functions. And so what we're going to try to do today is to describe how the graph of an exponential function changes under different transformations. We've practiced transformations already with different kinds of graphs, and so I'm just going to go through the different things that can happen when you transform any kind of graph, but here specifically we're talking about exponential functions. So the first one is where it says reflect right there. Anytime you have a negative out front, it can cause the graph to flip or reflect across the x-axis, so it can flip the graph upside down. The next thing that can happen is either a stretch or a compression, and so we'll practice looking at different examples of what stretches and compressions mean as we go through the notes today. And then these are the transformations that we practiced before too. So it says that if you're going to have a number as the base, that's going to be your number inside the parentheses. And then up here, it says x plus or minus. It says if it's a x plus something, it moves it to the left, and if it's x minus something, it moves it to the right. And so we remember talking about how inside was opposite. For this one, you're going to have to think that the exponent is opposite. And then the number over here that comes after the part with the exponent, if it's a plus number, it moves it up, and if it's a minus number, it moves it down. So we're going to be using exponential functions and talking about how they shift. In the first example right here where it says exponential function, an exponential function is defined as being a function with a variable up in the exponent. And so for the sake of the example here, the exponential function that got chosen was y equals 2 to the x power. And so we can fill out the table for 2 to the x power. I usually like to start with the positive numbers first. So 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. Remember, to get these numbers, I'm just taking each of these numbers and I'm plugging it in up here for where the x is up in the exponent. Any number raised up to the power of 0 equals 1. And then remember, negative exponents don't make the 2 turn negative. It causes the value of this to flip into the denominator. So this would be 1/2 and 1/4 and 1/8. If you plug these into your calculator, they'll give you out decimals, but just remember you always want to write them as fractions in the table. Okay, so when I graph this, 0 goes with 1, 1 goes with 2, 2 goes with 4, 3 goes with 8 would be off the graph, so I'm not going to graph it. And then I've got 1/2 and 1/4 and 1/8. This function that I just drew in right here is going to be the one that we compare other functions to on the notes today. Sometimes this is called a parent function, and so y equals 2 to the x power is going to be the function that later in the notes we're going to be graphing some transformations to see how it moves, but this will be the one that we start with today. In example number, well, it's not numbered. In this one, the exponential horizontal shift, we're going to talk about how a positive number and a negative number up in the exponent make the function move. So the first one, f of x, that's right here, I'm going to graph that one in black on the notes. So 2 to the x power, we already have the values for that because this is the one that we went through and we graphed up above. Oops, just kidding, that's a 1. So this is the one that we just did the workout for in the previous example. So I'm going to go ahead and graph this one on the graph. We're going to be graphing the other two, and we're going to be comparing them to see how they compare to this one. And so I'm going to do the work for g of x here in red. To find the numbers that go inside the chart for this one, you can take each of these numbers and plug it in up here. But it's going to be a little bit different when you plug the numbers in. For example, when I plug in, let's see, I'll put the number 0 in first. When I plug in 0 for x, 0 take away 2 is -2, and then 2 raised up to the -2 exponent gives me 1/4. So I got the same answer as I did for that one, but it's in a different spot. When I plug in a 1 exponent, 1 take away 2 is -1, and then 2 to the -1 power is 1/2. When I plug in a 2 exponent, 2 minus 2 is 0, and any number raised up to the power of 0 equals 1. So you're going to start to see kind of what's happening. It's like you're getting this answer, but you're getting it for 2 numbers over to the, like, 2 spots over to the right. Like the 1/4 would be here, but now it's here. The 1/2 was here, and now it's here. And so this would be the number 2. And then as I go this way, let's see, the next one over would be 1/8. And then this one, if I plug it in, if I plugged in a -2, I get 1/16. And for this one, I would get 1/32. And these numbers you would actually get for this one too if the table went over further. But I want you to see that pattern, that you get this same number, but it's 2 to the right. You get this same number, but it's 2 to the right. So what ends up happening when you graph this, let's see, 4 goes with 1, 2 goes with a half, and then a 4th, and an 1/8, and a 16th, and a 31st. Let's see. Oops. Did I make a mistake? 0 goes with a 4th, 1 goes with a half. Yeah, I did. I put these points in the wrong spot. I just got to slide them up a little bit. I was looking at this number and graphing it with this one, but I have to look at this top row. So 1 is supposed to go with a half, and then 2 is supposed to go with 1, and then 3 is supposed to go with 2. So that point over there was the one in the wrong spot. When I graph this one, it kind of looks like a little bit taller, but that's not what's different about it. What's different is that this point that was in black is moved over 2 to the right, and this point that was in black is moved over 2 to the right. So all of the points got shifted 2 to the right. So that's what the -2 did up in the exponent. If it's a negative number up in the exponent, it's going to move it to the right that many number of places. The opposite happens when it's a positive number up in the exponent. So when I plug each of these numbers into the last one, each of x, I'm going to do this one in blue. Kind of looks black in the video, sorry about that. It is a different color. You might want to do it in a more obvious different color. When I do the work for this one, let's see. I'll start by plugging in the number 0. 0 plus 3 is 3, and 2 to the 3rd is 8. 1 plus 3 is 4, and 2 to the 4th is 16. And then 32, and then 64. So it's hard to see what's happening this way, but when I fill in the rest of these, it might make more sense. When I plug in a -1, I get 4. And when I plug in a -2, I get 2. And when I plug in a -3, I get, oh my gosh, not 0. I did it again. Any number raised up to the power of 0 equals 1. So I get a 1 when I plug that in. So comparing what happened on this one, I still got a 1 and I still got a 2, but they weren't in, they didn't show up in exactly the same place. And so, again, we're not comparing it to the red row, though. We're comparing it to the black row. So compared to the black row, you still got a 1, you still got a 2, and you still got a 4, but look where they were located. They went 1, 2, 3 to the right, and this, or to the left, and then the 2 went 3 to the left, and then the 4 went 3 to the left. So what happens with a positive number is that it moves it to the left, and it moves it the opposite of the number that's up in the exponent. So this one went 3 to the left. When I graph it, let's do this one right. -3 goes with +1. -2 goes with +2. -1 goes with 4. And then the next one would be up off the graph. It kind of looks taller, but it's not taller. What actually happened was this point that was here went 1, 2, 3 to the right. And this point that was here went 1, 2, 3 to the right. So a number up in the exponent is going to move it horizontally. Horizontally is either left or right, and it's going to move it the opposite of the number that you see. And so the last type of change or transformation that we're going to look at is what happens when there's a negative out in front. So on this one, same thing. I'll start by graphing my original graph. 1/4, 1/2, 1, 2, 4, 8. I'll start by graphing my original graph. 0 goes with 1. It's good to remember that on the regular graph, 0 is going to go with 1 because that'll help you figure out the y-intercept later when you're trying to practice that. Alright, there's my regular graph. And so on this one, there's only one other picture, so I'll just do the other graph here in red. If there's a negative in front, let's start with 0. -2 raised up to the power of 0 is still 1, but then see how the negative isn't in parentheses? That means that the number is just going to be the opposite sign. So same with this one. 2 to the first is 2, but then the negative makes it -2. 2 to the second is 4, but then the negative makes it -4. And so on this one, you're looking at the fact that it's the same numbers here, but it's just the opposite sign. So this would be -1/2, and this would be -1/4, and this would be -1/8. So instead of going with 1, 0 goes with -1, and 1 goes with -2. And so what's happening, as you look at the picture of the graph, it's the same graph that we just graphed. It didn't get moved up or down, but what happened is it flipped. So if there's a positive number out front, that's the regular one that we graphed first, there's no reflection. But what happens in red when there's a negative number out front, there's a reflection. And you can say that there's a reflection or that there's a reflection across the x-axis. So it takes the normal graph that's up here on the top and it kind of looks like a mirror and it flips it down here to the bottom. And again, it's that negative out front that makes that happen. So whenever we're graphing these and we're looking at how they change, you always have to have the one that you start with first, and then you compare that one to the new one. So part A on this says graph the parent graph of f of x equals 4 to the x on each coordinate plane below. We haven't graphed 4 to the x together yet, the regular one, y equals 4 to the x. So I'm just going to make a little table over here so you know where the points are coming from. Any number raised up to the power of 0 is 1, so 4 to the 0 power is 1. 4 to the first power is 4. 4 to the second power would be 16 if it was going to fit on the graph. So 1, 4, and then 16 doesn't fit. And then if I plugged in negative numbers, remember it just turns it upside down. So that would be 1/4 and 1/8, or sorry, 1/4 and 1/16. And then 1/32. So this is what the regular graph looks like. I'm going to go ahead and graph that graph. 1, 4, 1/4, 1/16. I'm going to graph it on all three of these because it's having me do the same graph for all of them. So 1, 4, 1/4, 1/16. And the 1/4 and the 1/16 that I'm getting out as answers are because I'm plugging in a -1. That gives me 1/4. And when I plug in a -2, that gives me out 1/16. This is kind of a, well, it's not kind of, it's a really weird order to write these in. Normally we do them in either increasing or decreasing order. So that's the regular graph that we're going to do the comparison to. This isn't this graph, it's this black graph up here. This is the one that I'm graphing in sort of the standard color. And then when I do the work for these, I'm going to do them all in red. So it says to graph each of the given functions on the coordinate plane and then describe the transformations. So we're not going to make tables for all of these. When we do the work for them, we're going to try to just compare them to the parent function and practice what we did. There's a +4 up in the exponent. And so if you refer back to the notes over here, when there was a plus number up in the exponent, we said a positive number up in the exponent moves it to the left. So the +4 here that's up in the exponent is going to move the graph to the left 4. Now I could make a table to help me do that, but I don't have to make a table because instead I can just take each of the points that I graphed and I can move it 4, 1, 2, 3, 4 to the left. And I can move it 1, 2, 3, 4 to the left. And then each of these would also move 4 to the left, except I kind of run out of space on the graph that I gave you. So that graph right there would be the graph of g of x, which is the regular graph moved 4 to the left. And you could plug in any of these numbers to make sure that you have these points in the right place. Okay. On the next one, there's two things that happen. So there's a -3 up in the exponent. And so on the previous page, we had a -2 up in the exponent. And we said that moved it 2 to the right. And so let's see, a -3 means this graph is going to move 3 to the right. But then there's something else that happens too. There's a negative out front. So there's also going to be a reflection across the x-axis. Now, it can be tricky to do both of these at the same time. It's up to you to decide how it works. I actually prefer to do the reflection first and then move it 3 to the right. So I sort of do these in the other order than they're written, but you can do it this way too. It's up to you. So what I do is I say, okay, this point's right here. So if I were going to flip this upside down, the positive one would flip down to -1, and then it moves 3 to the right. 1, 2, 3. So this point became this point. Now I'll do it again with the 4. This one was up at 4, so if I flipped it, it would come down to 4, but then it also has to move 3 to the right. 1, 2, 3. This point right here is at 1 over 4, so if I flipped it, it would be at -1 over 4, and then it has to move 3 to the right. 1, 2, 3. And you could move any of these other tiny little points 3 to the right as well after they flip upside down. So when I graph this one, make sure I draw this in the right spot, it didn't move down, even though it looks lower than the first one. The negative out front caused a reflection, and then the -3 up here caused it to move 3 to the right. And again, you can write these in either order, and you can actually do the counting in either order as well. Let's see, that was for h of x. And so for this one, for k of x, there's a big +1. And on the previous page of notes, we said that when there was a +1 on the outside, not up in the exponent, but like later, it's going to move the graph up or down that many units. So on this one, the +1 is going to move the graph up 1 unit. And again, I could find the red graph by plugging in and making a table for all the points, but I can also just recognize the transformation. So the 1 is going to go to 2, the 4 is going to go to 5, the 1/4 would go up here, and then this one would go here, and this one would, if there was another point, it would go there. So these ones are kind of close together. It's hard to draw them as an accurate picture. But the red one is just the black one moved 1 unit up. Something that I didn't say about the previous question is that the 4 on all 3 of these doesn't do anything to change where the graph is located. The 4 is the same as this 4 here. So you always have to have a number in your base. The base doesn't move the graph, it's the other stuff that moves the graph. So for example, on number 2, it says, given the parent function y equals 8 to the x, if we were going to graph them, this would be our black function. This would be like the normal one that we started with. And then each of these, when we do the work for the equations, these would be the new graphs. So on purpose, I'm going to write this in a different color. Let's see. They want us to write the equation that results from the following transformations. So this is the parent function. This is the one that you're starting with. And so all 4 of these are going to start with y equals, because I'm writing equations for all of them. And then all of them are going to have the number 8, and then they're going to have other stuff too. I left this awkward space because I think one of them has a reflection, and so one of them is going to need a negative out front. The other ones you wouldn't need to put anything in this awkward space. Alright, oh, they're also all going to have an x up in the exponent, but they might have other things up in the exponent too. See how I took this equation and I kind of just spaced it out a little bit, and now I'm going to add in the other stuff that I need. So if it goes 9 to the left, you want to look back onto the front of your notes. Remember that when you move it to the left and right, the number has to be little, and it goes up in the exponent with the x. So for this one, if it's going to go left 9, it's always the opposite of the way that you think. So +9, little, and up in the exponent would move this graph 9 to the left. On B, if it's reflected across the x-axis, it's going to need a negative out front. And then if the whole graph gets moved down 6, remember to move the graph up or down, you're using a big size number, like a regular size number, and the up and down transformation goes the way that you think, and it's not up in the exponent, it's a large number that's all by itself. So for this one, if it goes down 6, it's going to be a regular size -6, not a little -6 up in the exponent. C has 2, so it goes right 7, so right is a little one, it goes up in the exponent, and it's the opposite of what you think. So there's going to be a little -7 up in the exponent for this one. And then it says that it goes up 2, so that's a regular size +2. And then the last one, they switched the way they worded the question. So the down 8 units means that there's going to be a -8 over here, because remember, the number at the end moves it up or down. And then it says it's going to move it 1 to the left, and so there's going to be a little +1 up in the exponent, and that's going to move it 1 to the left. So this last example is a really good one because the numbers, you don't put them in like this one first and then this one second. You have to put them where they're going to go to cause the correct transformation to take place. And so on number 3, It's exactly the same thing, except they're giving you this, and they're asking you to do this and to write the words out for this one. Remember, there always has to be a base. And so on this one, y equals 7x, this would be your parent function. So if you were going to graph it, that would be the one that would be graphed in black. And then each one of these would be the new one that would be graphed in a different color. And so on all of these, you would just be describing how it changed. So let's take a look at the first one and see how the first one changed. Y equals -7 to the x minus 5. So the 7 does nothing because the original graph started with a 7. But the negative out front would cause there to be a reflection across the x-axis. And then the little -5 up in the exponent, remember from the front of your notes, the number up in the exponent moves it right or left, and it moves it the opposite of the way that you think. So that means that the -5 up in the exponent on this one is going to move it 5 to the right. On the second one, the +2 in the exponent is going to move it 2 to the left. And then the -3 on the outside is going to move the graph down 3. And again, we're comparing all of them to this function. So that would be the original one, and this is the new one that's moved. And then here's the original one. On this one, there's also two things that happen. The minus out front causes a reflection, and then the +8 at the end would move the graph up 8 units. So you're giving the different words that tell you how the new graph would be different from the old graph or the parent function.